diagram had an actor. Now I can show you this picture of an actor here. He is called as an actor. Now I will demonstrate to you a very simple example, live example on how inheritance is done in object-oriented programming. For that, what we will do, we will take the example of your college.
Yes.
See, yesterday I told you, you have to identify nouns in your college. So, what are the nouns you identified? Lecturer was one noun, correct?
Faculties, principal.
Lecturer or faculty, whatever you call.
Yeah.
Then HOD was another noun.
Yeah. Principal.
Principal, will not leave him.
Yes.
So, we will identify three nouns. One is lecturer, one is HOD, and the third one is called as a principal. Now what we have to do, now each and every noun is associated with a verb, which means lecturer has got certain functions to perform. HOD has got certain functions to perform. Principal has got certain functions to perform. Do you agree?
Yes.
Okay. See now,
yes, sir.
Every person here has got some activity in the college. Why he is called HOD? He is called head of the department because he performs more responsible activity than a lecturer. And why he is called principal? He is the head of the college because he is responsible for the entire college. So the activity done by a principal cannot be done by a lecturer. But activity done by a lecturer can be done by a principal. I'll explain to you very clearly. Now, first we shall take an actor called as a lecturer. Now, he is your lecturer. Now, yesterday I told you that every noun will have something called as actions. So, what are the actions of a lecturer? Yesterday we saw this. I will draw some 2-3 actions. It is enough. The first action is he will handle class. So this is the first action of a lecturer. So he will handle class. Then the second action of a lecturer is he will mark attendance. I'll just add here it as mark attendance. And the third action of a lecturer is he will set question paper. He will set question paper and he will evaluate answers. Is this clear to all of you? So this class is very interesting. Now you have a lecturer. He will handle class, he will mark attendance, and he will set question paper. Now what I will do, I will add one more actor. And I will call that actor as, one second. Now I'll call this actor as HOD. Okay, this actor is called as what? HOD. Now, apart from, can HOD handle class?
Yes, sir.
Yes, sir, he can.
Can HOD mark attendance?
Yeah.
Can HOD set question paper, evaluate answers?
Yes, sir, everything he can.
Okay. What do you think is the additional responsibility of a HOD which is not there in a lecturer?
Some kind of department management system.
Very good, excellent. So what I will do is, I will add one function here for HOD. I will call it as, say, set timetable. And we shall do department management. So, department management. These are the two additional functionalities of an HOD. Is this clear?
Yes, sir.
Yes, sir.
Now, what I will do is, I will interrelate this HOD with lecturer like this.
Correct.
So, what does it mean? This lecturer, which means that HOD, whatever functions the lecturer performs, those functions will automatically be available to HOD, which means HOD can also handle class, HOD can mark attendance, HOD can set question paper, evaluate answers, but HOD has an additional functionality which is set timetable and department management. Is this clear?
Yes, sir.
So this is called as inheritance. What do you mean by inheritance? Inheriting the functionality of one actor into another actor is called as inheritance. So now I'm inheriting the functionalities of a lecturer actor into one more actor called as an HOD.
Sir, what is the definition again?
What is the use of doing this? See now, generally this is an use case diagram, correct? No, now when we are writing programming, we will not write like this. We are going to convert this use case diagram into program or a code, correct? No, what are we going to do? We are going to convert this into code, correct? So handle class, what does that handle class? It is a function performed by a lecturer. So I am going to write one function called handle class. I am going to write one function called mark attendance. I am going to write one function called set question paper. I am going to write one function called evaluate answers. Only one time I will write that function, that's all, and I can call that function either from a lecturer or from a HOD. So that means you are using this functionality either from lecturer or either from HOD. So we say that this particular function is reusable. Understood? Principal and son. So now what is happening? Father is inheriting some properties from grandfather and son is inheriting some properties from father. So that means this son, principal who is a son, will get the properties of both father and grandfather.
Yes, sir.
This is called as inheritance in object-oriented programming. Now arrows are shown like this. Now if you're seeing arrows like this, don't think that the properties from the principal are going to HOD. Properties of HOD are going to lecturer. It is not like that. HOD is getting the properties from lecturer. See, your father cannot give property to you. You can extract property from him. Understood now?
Yes, sir.
So this concept is called as inheritance in object-oriented programming. So where do we use this inheritance concept? We make use of this inheritance concept exclusively when we want to reuse the code. When we have to do the code reusability. Wherever we have to do the code reusability, we have to do inheritance. Okay, now you had lecturer, you had HOD, you had principal. Now all these things are called as what? Actors, correct now? So now what I will do, see now, this is all in the design. These are all design. So you are putting all diagrammatically, like, you know, in your electronics, first you do a PCB design. You write the design, then you convert the design into a circuit board, correct now? So similarly in programming, you must have done in C, there was something called as flowchart.
Yes, sir.
Yes, sir.
So flowchart, you cannot execute the flowchart directly in a computer. Can you execute the flowchart? No. You have to convert the flowchart into a program. Correct now? Similarly here also, you have to convert this diagram into a program. Then only you can execute. This is only for your understanding. Because you have understood that this is how the program is. You should know that lecturer will have these functions, HOD will have these functions, Principal will have these functions. Principal is inherited from HOD. HOD is inherited from a lecturer. So what do you do now? So you have to convert this particular actor called lecturer into a class. So what I will do, I will take one class now. So this is my class. Yesterday I told you class will have two sections. What are the two methods? So now, very good. Now here I have properties. On the top I have properties. So what I will do is, I will add properties here. So all these are properties. Okay, I'm going to add the properties. Let us not worry what are the properties are. Then HOD class, this HOD class is inherited from lecturer class. Is that clear?
Yes, sir.
Understood the concept very clearly?
Yes, sir.
Yes, sir.
Now, yesterday I told you for every class we can create an object. Correct? No? This is a class, lecturer, and this is a class, HOD. You can create an object. So what is an object? Yesterday I told you an object is an instance of a class. So what I will do, I'll create one object. So the name of the object, I will call it as Anil. Name of the object is Anil, and this object is an object which belongs to a lecturer class. Okay. Similarly, I'll create one more object, and the name of the object is we'll take one more person. The name of the object is Sunil. Oh my God! Just hold on. This is one object. This is one more object. So I created two objects. So this Sunil belongs to HOD and this Anil belongs to lecturer. Now, this Sunil can access this particular method. Which is that method? Handle class. Are you able to understand this?
Yeah.
Yes, sir.
Like why he can access? Because it is inherited. He can access this method. And he can also access this method. That is set question paper. And he can also access this method. That is his own method. What is his own method? His own method is set timetable and manage department. But these two methods, handle class and set question paper methods, were actually inherited from which class? Lecturer class.
Lecture.
Very good. Now suppose if you take an object called Anil. Anil is an object of lecturer only, so nothing to worry. He can access handle class, okay, and he can also access set question paper, but he cannot access this. These two he cannot access.
Yes.
Understood?
Yes.
Okay. This is called as single level inheritance in Java. Oh, sorry, I'm saying not Java. I'm sorry. In Python or any object-oriented programming.
What's a single line?
Single level.
Single level.
Yeah. Single level means HOD and lecturer. That's all. If you add principal to this below, it will become multi-level. Understood, no? So now we will understand. Now we will call lecturer as a base class. You just remember it is called as a base class. Any class which is on the top is called as a base class. He is the base. For example, you can see here, lecturer was an actor. From him only everything started, no? So we call him as a base actor. HOD was called the derived actor. So that means HOD was derived from lecturer, but principal was also a derived actor of HOD. So for principal, HOD is the base. For lecturer, for HOD, lecturer is the base.
Mm.
You understood this?
Mm.
Yes, sir.
So for everything started from grandfather, then father and son. So you can tag it with inheritance. So we call it as a base class and a derived class. So there are different questions they ask in the interview. So you can either call it as a base class, or you can also call it as a super class. Super means topmost class.
Mm.
And you can call the derived class as subclass. What is it called? Subclass.
Subclass.
SUB. Okay, I will write it and show it off to you so that it will be clear for you. I'll take a new document. 1 second. So now you understand. So you are writing like this. So you can call it as base. Then from base class, you are getting the derived class. You are getting one more derived class. Like this, it goes on. So this base class is called as super class. And the derived class is called as subclass. And you have one more subclass. Understood?
Mm.
So this kind of inheritance, what you saw, is called as an multi-level inheritance because there are 3 levels. What are the 3 levels? Grandfather to father is one level. Father to son is another level. So there are 3 people involved. Multi-level. Any doubt here?
No, sir.
No, sir.
So there are different types of inheritance in object-oriented programming. The first one you learned is called as multi-level inheritance. The second one is called as multiple inheritance. You should know the difference between multi-level and multiple. So what is multiple? I will take one. I will give you an example. What is multiple inheritance? See, now I am having something like this. I'll just show you the figure. You can understand. This is one class. Okay. I will add one more class. And I will add one more class. Now what I will do? I will So this is one base class, this is one more base class, this is one derived class. So now this derived class has got 2 parents. This is parent 1, parent 2. Father, mother, child.
Mm.
In this case, in the earlier case,
No, this is different.
this is multi-level, this is multiple. So when I say when I use the word multiple, which means it is more than one parent.
Mm.
I try this here.
Yes, sir.
What is multiple inheritance?
In multiple inheritors, there are hello.
Hello, I can hear. Go ahead.
Network চলে যাচ্ছে
Hello.
Hello.
Yes, I can
Yes,
hear.
sir.
What
Yes,
is
sir.
multiple? Define.
Yes, sir.
Give me the definition of multiple inheritance.
It's more than one base sector is there. Sir.
More than one parent. More than one parent.
One parent.
Is that clear?
Yes, sir.
Okay. Now the third type of inheritance is called as hybrid inheritance. Hybrid inheritance. Now the moment you say hybrid means it is the combination of multi-level and multiple. So what I will do here, you just observe now. I'll put one more class here and I'll draw one line here. Understood? So now what is happening? So okay, we'll name them. So we'll call them as A, B, C, D. Okay. Now A is one class, C is one more class. C is derived from A. Correct?
Yeah.
This is multi-level. So father-son relationship. C is the son, A is the father. Now there is one more class called B. B is not derived from anybody. It is independent.
Yes, sir.
Now D is derived from B and D is derived from C.
Yes, sir.
Multiple. But C is derived from A. Multi-level. So you are having multiple and multi-level both. So this is called as hybrid inheritance.
Okay.
Yes, sir.
Okay.
Understood?
Yes, sir.
Sir, one more time.
Okay. One more time I'll tell you. Okay. See now, you have four classes now. A, B, C, and D. There are totally 4 classes. This C class is derived from A class. Aisha, is that clear?
Yes, sir.
So what kind of inheritance is this? You have son and father relationship. What kind of inheritance?
Multi-level.
Multi-level. Correct? Multi-level. Only one level. Now, there is one more class called B. B is not derived from anybody. It is independent. Now you have one more class called D. D is derived from B and D is derived from C. So D has got 2 parents. One parent is B and one parent is C. So this is multiple.
Multiple inheritance.
But this C is derived from A. So by default, D has got one parent, that is his immediate parent, and one non-immediate parent. So C is derived. That means C is the father of D, and A is the grandfather of D, and D also is the father of D.
Yes, sir.
Don't say mother, okay? I'm just giving you an example. So this is called as
Hybrid inheritance.
Inheritance. Sir.
Yes.
this is called as hybrid inheritance.
Yes, sir.
Like this, I can have any number of inheritance here. So now what I can do, I will just delete these things for you. I can have something like this. Okay, now you see what happens. See? Now what is happening? B has got one more father. C has got one more father. From B and C, I'm getting D. See, it is like this. You will take father, mother, son, father's father, mother's father, and son. So son and finally the derived class. So this derived class will get the properties of both the parents, and these parents would have got properties from their parents. Understanding, no? Okay, so this is called as inheritance in object-oriented programming. So why do we require inheritance? We require inheritance for only one purpose, because of code reusability. We can reuse the code. Once you write the code in the parent class, that is enough. I can make use of that code in any number of classes.
Okay.
Shall I give you an example?
Yes.
All of you are comfortable with banking, no? Banking system.
Yeah.
Yeah.
What are the different types of accounts in a bank?
Current account, savings account,
Savings account.
salary account.
Current account, savings bank account, recurring deposit account. Correct? So in any account, there are three functions: open an account, close an account, do transaction. Correct, no?
Yes, sir.
Now opening, and suppose if I write one method called open account, that method called open account can be used for opening a savings bank account, can be used for opening a current account, can be used for opening a recurring deposit account also. Only one function. It can be used for three different accounts. If this inheritance concept is not there, you have to write three functions. One function for opening a savings bank account, one function for opening a current account, one function for opening a recurring deposit account. So three functions you have to write. So here I'll write only one function and make it use in three different classes. So which means you are saving time. Number one, you are saving the time, you are saving the space, and also more importantly, you are actually improving the performance. That is why object-oriented programming is more powerful than structured programming. If I had to do this account opening problem in structured programming in C, I had to write three functions. One function for SB, one function for RD, and one function for FD, open, open, open. But in object-oriented programming, I'll write only one function and I will use it in three different cases. So this is the major difference between structured programming and object-oriented programming.